Hi everyone, and welcome to this week's Orchestrator meeting. I guess today is a Rook day. At least, let's see how much we can discuss about the Rook Manager module. So three topics are on the agenda for today, right? We have the presentation of Aaron about implementing the Gherkin language, and then we have the Rook Orchestrator status, where it would be great to in the end come up with an idea how to go forward with the Rook Manager module. And then Ceph devices. Okay, Aaron, do you want to start?
Yeah, sure. Let me share my screen. So as a G-Shock mentee for this year, I'll be working on Jacaranda language and language. So the Jerkin language is simply similar to a natural language where we can define our test scenarios easily and very for not requiring very technical people to also define it easily to how the system should work. And it simply uses given and when kind of keywords to run the scenario and assert the outcome of the scenarios. And as you can see, I have provided a sample scenario that we'll be implementing, saying that given as I log into a node as a root and I execute a specific I run the Ceph ADM version command so that then we assert that we should match with the version we get and what the version we expect here. And one of the main tool for this integration framework will be KCLI. KCLI enables us to create virtual machines in few seconds using the CMD commands and get it up and running in a few minutes as well. And we can define a environment that we wanted to run a specific test scenarios that we define, and we can simply using defining it in the feature, and we use the behave to pass these specifications and create using the KCLI plans. And KCLI uses a simple YAML file to define these variables. We can modify this number of nodes and number of CPUs as required, and we create this environment. And after creating this environment, we'll be able to run those the test scenarios we want. And as the dependency, we will be using a Python behavior-based framework as behave, and where it uses we use the Jacaranda language to define Jerkin language to define the test scenarios, and using the Python implementation to execute these scenarios. We can define multiple features, and in each feature we have multiple scenarios, and using the KCLI to create and manage and interact with these virtual machines. And yes, here is a sample structure of the feature file where we define the feature. Initially, we given a description what the feature is, and we define the environment where we are going to execute these test scenarios. As you can see, with for this example, it's 3 nodes with 4 gigs of RAM and 2 CPUs. And this here we use the behave to pass these specifications, and using the KCLI, we create a plan and get the KCLI tool as to create the virtual machines and get the machines up and running. and then there will be multiple scenarios similar to these scenarios here. We are using defined in Jerkin language, and we provide that we can say that we provide these, we execute these commands and we get these specific outputs. We assert that we get these specific outputs, and as you can see, it is much simpler to define a test case, and it will be easy to assess what kind of output we get. And this is the sample or overall structure on what the project will, how the project is going, how we are going to implement in this project. And we wanted to discuss with the community that where in what folder structure we will be able to create this, implement this project. The simple small presentation on what and how I'm going to do this.
Okay, thank you. Yeah, guess it's your turn.
One question related with that is for the team, okay? We are going to need to implement this, okay, in the current Ceph folder structure, okay? But what could be the better place in order to implement this this test framework?
I mean, it's a bit in a bit similar to tautology, right? With the exception that we are using KCLI and virtual machines instead of hosts maintained by tautology.
Yeah.
Yeah, please.
Yeah,
Again?
I wonder if the place where it seems like it might be helpful, or anything non-tautology actually, would be like bootstrap tests, where having a virtual machine and sort of cleaner environment would give us, you have more arbitrary setups. Like, you know, the example of the SSH user thing, right? Where we have to, they're just like annoying environmental changes that we want to make sure work.
OSD deployment. We don't have proper OSD deployment tests in Ceph ADM.
Yeah, that too. Yeah.
We have extremely limited OSD deployment in tautology because they are kind of physical disks, right?
Well, the idea here is that well, if you have the code and you run the test, this kind of test is possible to be run in your laptop, okay, or in your development machine, okay. So it's a way to execute in a quick, fast, efficient way integration test, okay. That in this moment, well, we need to do a lot of manual steps in order to achieve that and to wait for at least 1 day in order to get a result, okay, with the tautology runs. So this is just another way to execute this integration test. The important thing is not where the tests are going to be executed, because you can execute this test directly in your laptop, for example. The important thing here is just to have a place where we can put the the implementation, okay, in order to make easy the execution of this test for all the team.
That really reminds me of the integration tests that we have for Ceph Volume. Because Ceph Volume also makes use of virtual machines for its integration testing. The difference is that the integration testing in Ceph volume is done by Tox and orchestrated by Tox. I mean, why not? I mean, it's a Python framework. Can we integrate that Gherkin or behave framework into Tux? Would it work? I mean, I wouldn't I don't think it makes sense to run it on MakeCheck, right?
No.
Yeah. I have a more general question about the Gherkin thing. Is the purpose of Gherkin that it's natural language and so it's easier to write the tests, or is there something functionally that it does different than?
No, I think that what the target of the Gherkin language is just to provide natural language, a very easy way to write tests, okay? In order to make this possible to write tests for people that are not developers, okay? The thing is that the steps that you have into the Gherkin language, the different features that you want to test, you need to implement some things. For example, you need to implement some way to execute a command and to get the output, and to compare this output with an expected output in order to see if the test is passed or not. Okay, so the target of the Gherkin language is just to provide an easy way to describe tests.
Okay. I guess I'm just wondering what the goal then is. I mean, are we trying to expand the number of people who can write tests? Because I worry that if it's a natural language description, but the actual behavior is precise, like we're still running specific commands and checking specific output, like that seems dangerous to me, because if there's a failure in the natural language processing, then you have to debug that as opposed to have something that is very explicit about exactly what it is that we're.
Well, it depends of the things that we implement, okay? Because the natural language that you put in the test should be you need to have something in order to implement these steps, okay? So I think that we can start with something very simple, that is just execute a command and compare output.
Yeah.
And the target, I think that is we have two targets with this. I think that the two things that are important. One is to provide the capability to write tests to people that is not a developer. And the other one that I think that even is more important is to have some kind of integration test that can be run fast, efficiently in your own infrastructure and without any dependency of external resources.
But the thing that really strikes me is that we have gaps in tautology. So the third goal is really to fill those gaps, like bootstrapping or C deployment, where we don't have anything right now. We don't have any tautology tests. We don't have any proper unit testing. We don't have anything. So
yeah,
that's the thing that I care about the most. It feels like there's the set of people who are going to be motivated and inclined to write tests, but who can't handle Tox, Python, or whatever to write those tests is very small compared to the total number. So I'm a little bit skeptical about the natural language part. But the gaps, I really want to fill the gaps with all the OSD, especially with the OSD deployment scenarios. I feel like those are
Okay, that could be nice. Okay, but well, in any case, I think that we do not forget that this is just a Google Summer of Code project. Okay, and what we and our the main target is to just to make the experiment, to show the possibilities, and to see if it is worth to invest more time in that. Okay, I think that I think that. We can obtain several advantages with this kind of work. Obviously, we cannot replace tautology because we have a lot of functionality in tautology. That is not the target, okay? It's just to have another tool that could be useful for some kind of things, okay? So,
I guess my suggestion then would be to focus around the testing gaps then, I guess. Like I don't think we should try to invest in replacing, like, yes, being able to run all of our testing on your laptop, it would be great, but like the reality is that we can't do that. And there are lots of other reasons. So I think if we focus around like things that Tautology doesn't test and take advantage of things that KCLI and virtual machines do provide, for example, all the device management scenarios that we want to be able to cover, like that sounds like time very well spent, I guess.
Okay.
Yeah.
Okay.
I don't have any strong opinions on the tools, but.
Okay, just to in order to make easier to start with the project, we need a place where to store the code. So, Sebastian, you have proposed the docs folder?
No, Ceph volume. Make it similar to Ceph volume.
Inside the Ceph volume folder?
There is Ceph volume. In the Ceph volume module, there is an integration test, and that's hooked into Tox.
Same thing, but inside the Ceph ADM folder.
Yeah,
I think that I think that is more related. Okay, and even we can start just with Ceph ADM test. So maybe I like more inside Ceph ADM in a separated folder. Okay, in order to.
Yeah. Have a look at this folder here as an example, as a template.
Okay, but the thing is that this framework, Sebastian, is something that is general. Okay, it's not related directly with the volume. So I think that
use it as a template. Use it as a similar way to integrate functional testing into Ceph ADM.
Okay, so we can use, for example, into the folder SRC, okay, we can create, for example, a new, for example, behave test, okay, folder, and inside that folder, create our infrastructure.
Yeah, for example.
Okay, perfect. It's clear. Thank you.
Having it executed without having it executed mandatory on pull request or having the possibility to run it on pull request is kind of pointless, right? Tests written without automatic verification of the test are pointless. So, how do you want to integrate that? Do you want to integrate that into tautology, or do you want to integrate that into a Jenkins job?
I think that the right place is Jenkins.
Yeah, I think so too.
Me too.
And very easy to integrate with Jenkins, I think.
Yeah.
Okay. Aaron?
Yeah.
You happy?
Yeah, I think I can start working on it.
It's a big question.
Yeah.
I think that he will have everything implemented in a couple of days. No worry.
Sounds great. Can't wait for next week.
Looking forward to the pull request.
No pressure, Aaron.
Okay, next
All right.
topic.
Should we talk about the Zap thing really quick?
Yes.
It'll just take a minute. Basically, that change that you made to call Orchestrator Zap whatever, it adds an extra dash destroy when it calls that volume, which destroys the LV.
And
I'm not quite sure how we should proceed. I think that's probably the right behavior for that Zap. We could add a flag to the orchestrator that's like no destroy LV or something like that. That maybe, I don't know, that seems kind of awkward. Or we
no,
could
I don't like that. Okay.
We could go back to what we were doing before, but then have like a device refresh. But the problem with that is that device refresh is asynchronous. It just triggers a refresh, but it doesn't block for the refresh. We don't have a blocking command that waits. But we probably should, right?
Well, I don't like to avoid this behavior in the orchestrator. I think that is the right thing to do to destroy and to clean completely the device. I think that is the right thing to do. So, well, we can add the flag just to make easy to run the test. Okay.
Yeah. What if we do a Ceph ADM refresh devices command that's blocking? And then we could call that, because I think right now in the orchestrator interface there's no blocking command.
Yeah.
Yeah, because of good reasons, you know.
Yeah. Well, it seems that the best thing or the thing that is less worst is to add the flag to the command, okay, in order to avoid to use the destroy flag in the LVM command. So I will change that for tomorrow.
Go ahead. I think adding the flag adds it to the orchestrator layer, which means that will affect like Rook and Ceph ADM. Yeah, I don't know. I'm not sure. I'm a little bit.
Regarding Rook, you know, I mean, when dealing with Ceph volume, we're going to have the same issue. So if we just expose the CLI options of Ceph volume, I think we're good. We just have to think about persistent volumes. If tapping persistent volumes, I don't think that's a thing, right? They're just gone afterwards.
Yeah. So would the flag be like no -- no destroy? I mean, right now the default behavior is to pass -- destroy. So would we add like a -- no destroy LV flag to Is the chat broken for you guys? I keep posting stuff in the chat and it's not showing up.
No, it's not showing up.
No.
Yeah. Okay. Weird.
Yes.
Yeah. So maybe we add a flag that's like -- no destroy, so that it doesn't pass destroy, so that we don't change the default behavior.
Can we keep the very same behaviors as Ceph volume?
That would mean changing Zap, the behavior of Zap exists right now, because right now Zap by default passes -- destroy.
Yes.
So you're saying we make a change.
Yep. If we already have a behavior change between Ceph volume command and Ceph odds command, I think that's wrong, right? No one will get it.
Yeah, I think you're right. Yeah. Okay. So we'll add a -- force that'll default to false. Right. Okay.
Yep.
Sounds good.
So finally, we are not going to add the dash no destroy. We are going to avoid, if we do not use force, we are not destroying the device.
Yep. Let's keep the volume CLI and the Ceph Arch CLI compatible.
Okay.
If we want to change that, right? Then we should also change it in Ceph volume. Having two different commands that are
behaviors for the same, yes, is
no one will get it. Really, no one will get it.
Okay.
The concept that we are exposing is we are going to run this command on all the different hosts, yeah. And if we then have subtle changes between how we do that, right? It's problematic.
Yeah. Okay. I will change.
Sounds good. All right, Rook. Let's do a quick update first on the stuff that Joseph was working on this last couple of days. I basically asked him to look into LSO and just fiddle with it, understand how it works or doesn't work. Joseph, you want to summarize what you found so far?
Yeah. So basically, what I very simply, I just tried to get Rook working using LSO to provision PVs, and then Rook consuming those LSOs, or those PVs, and yeah, I mean it's not very complicated. You just run the LSO first, and then you run Rook, and it's actually quite simple. The LSO has kind of this automated way of creating PVs based on whether a device is valid or not, and it's just super easy to create those PVs in the storage classes. And then Rook, depending on how you set up your cluster, you can just tell it to consume those PVs, and it does it. And yeah, it's not very complicated, but yeah, that's about it.
That sounds like if LSO is really the way to go for Rook, then we should probably avoid making use of the legacy way of setting up drives and only go for persistent volumes.
I think, yeah, I mean, I would be a little bit hesitant to like completely remove the old support, but I think we should focus all of our efforts on the new, basically. I have one sort of lingering question about, well, I have a couple lingering questions about just making sure that LSO is really going to fit the bill. So I think the first is that the test that Joseph did was basically telling Rook to consume PVs when creating the cluster CRD, like on startup. And I think when you do that, you just say, you just basically specify how many OSDs you want to create, right? Like it's the number and the storage class, and it'll go and provision that many different PVs from that storage class. Was that right?
I don't think you actually specify the amount of OSD. I'm not entirely sure. I don't completely have a grasp over it, but okay, if you look at the pad that I linked, and then if you go down to the contents of LSO cluster test.yaml, so that's actually like the kind of Ceph cluster definition. And if you look
where did
at
you link it?
It's in chat if you can't see.
Yeah,
chat.
I've added it to the pad.
Yeah, chats. Okay.
Yeah. So you basically, from what I understand, yeah, you define a storage class device set, and then you tell it like how many OSDs you want to set up in that set, and then that set also has like characteristics. So you're saying like, I don't want devices with less than like 5 gigs of storage. So
yeah. Okay.
But yeah.
Okay, so I think that makes sense. That makes sense for like the I'm going to bring a cluster up scenario. like if you're using EBS or something like that. But I think the case where this matters is when you're running this on bare metal, where you have a set of machines, you have like specific devices and specific slots, and you want to like create an OSD with like this. You want to create an OSD on this device, basically, right?
But
so
what
I think,
about the common DB device? What about a common?
Yeah, that's the second. that's my second question. But ignoring that, first of all, like let's say like just the case where I have a machine, it has 10 slots. These are the devices. Like I just want to see the inventory, see the specific devices that are in there, like with their model and serial number, and hopefully like all that metadata about them. So I think the discover thing that you did, where you have a discover and discover result, I think that covers that, but we should sort of confirm that we can identify them. But then you say, I want to create an OSD on like this particular device. We have to figure out how you actually do that. Like, can you tell Rook to consume like a specific PV? Is that something that we need to add to Rook, or is it something that it already does? So you can say like create an OSD on this device. So I guess that's the first thing, and then the second thing, right, is the block DB. Oh, go ahead.
Which means that creating OSDs is kind of a two-step approach. One is to specify LSO to expose the right PVs, and the second step is to make Rook consume those PVs, right?
I think, I mean, it really feels like there are probably like multiple ways that you want to do this, right? Like if you have the orchestrator or Rook or whatever in a mode where you're like just use all available disks in this class, it should just like, if it sees a device, just hoover it up and create an OSD. Like I think that's one mode of operation that users would want. But I think a different mode of operation would be like I guess more towards like a day 2 where like there's a disk that failed or I had to pull it out, I removed it, I put a new one in, now I'm going to rebuild an OSD on that. Like a more like imperative, whatever, manual process. And maybe it's just my paranoia, but it like feels like we want to be able to do both, even if the manual process is just a building block for the automated process. But I don't know, maybe we should just not be thinking about that. It should all be automated. It just makes me nervous when there's too much automation going on.
We really should think up with Rookfox.
Yeah. But I guess that's sort of maybe this is a discussion to have with Rook. The second part of this is like an LSO question, and that is if we want to do the carve an NVMe up. If we want to carve up an NVMe into a bunch of pieces to use as the DB device for a bunch of hard disks, I don't think that LSO does that. Like LSO doesn't create a bunch of LVs. It doesn't. I think LSO might not handle that. There is this thing called Topo LVM or whatever. That's a different dynamic provisioner that basically is it's just basically an LVM type storage manager thing for Kubernetes. That might be a fit for that second part, but I'm not totally sure. It might not. I don't know. I'm not sure.
Well, I think I think that Sage, you have presented your first question or your first point. I think that is the important in this moment because we need to decide what to do. Okay, because the current interface that we have in the orchestrator, we have creation of OSDs, and we need to do a couple of things: host and physical devices. And this is not the things that is needed in Rook, okay, in a Ceph cluster in Kubernetes because they are using directly PVs. Okay, so maybe I don't know if it is worth to assume that this is not going to be possible to work directly in the orchestrator with devices, and maybe we should or we must add new endpoints in order to create PVs or to ask for PVs and to create OSDs in these PVs. Okay, I'm not trying to make work what we have in this moment. That is something that is completely oriented to bare metal environments without any Kubernetes platform. And well, just to assume that it's a different platform and we do not have control over the hardware. We only can, the only possibility that we have is just to request resources to Kubernetes and add a new set of endpoints just,
yeah. Well, I think you're right that for an environment like AWS, where you're consuming PVs from like a real dynamic provisioner like EBS, then I think you're right. I think we need new interfaces. The current orchestrator abstraction just like doesn't work at all. But I think for the case where you're running on bare metal, like the current interfaces make some sense where I just want to know what the physical hardware is like that's attached to physical hosts.
Sage, the problem is that the bare metal way of dealing with devices in Rook is super incomplete and nowhere near what you can do with drive groups and what you can do with Ceph volume. So even though, that's kind of the bare metal way of doing things with Rook, it's still anything but comparable to Ceph volume or to Ceph ADM.
Yeah.
And they even removed drive groups. So
yeah.
Is Rook really interested? Is really a good fit for bare metal deployments?
I don't know. That's a good question.
If you really care about performance, right? If you really care about performance and you really want to have host networking, you really want to have the volume directly accessed, and what's the use cases between Ceph ADM and Rook? Is it at a point where you really are interested in bare metal? You still want to use Rook like you would use Ceph ADM with bare metal capabilities, or do you actually switch over to Ceph ADM at that point? I don't know. Really, I don't know.
Yeah. Yeah. Well, I mean, maybe another way to look at this is, what do we want to be able to manage from the Ceph dashboard when you're using Rook?
Definitely PVs, because it's a main use case.
Yeah. I mean, I guess maybe that's the place to start.
Yeah.
And this sort of like, does it fall on bare metal? We can answer that later. Well, I wonder then if the place to start with just bringing the Rook stuff up to date is not on OSD's end, but on all the other stuff. So somebody put this paste bin here that has links to like a whole bunch of. It just went through like every CLI command, it looks like.
Yeah, it's me. I have take a look, just try to summarize what is the current state. And the good news is that we can enable the Rook Manager module. And this is all the good news, basically. No, it's not working, nothing. It's
Nothing else
a
works.
completely disaster. A complete disaster. So,
yeah.
well, I think that there's a lot of things to do. Okay, but I think that the most important thing in this moment is just to decide how we are going to manage OSDs. Okay, in Rook environments. So
Yeah.
we need to take a decision about that. And I think in environmental environments, I think that if somebody is going to use a environmental environment, a dedicated host, set of hosts in home, okay, probably they are going to decide to use Ceph ATM, okay. If you decide to use Kubernetes, it's because you do not want to have real control or detailed control of the physical devices that you are going to have, okay? Because probably you want to run this kind of features or utility in Amazon, in cloud services, or maybe in just any kind of Kubernetes environment. So probably you want to deal directly with PBs, not with devices.
Mm-hmm.
I think that's true today. I'm just not sure if that's the long-term vision, but
I don't know.
I guess we got to focus on the today part. Yeah, I mean, looking over this pad at things like, host labels. I mean, Kubernetes supports labels, right? I feel like we should probably, that's something we could wire up.
Adding hosts, removing hosts, I don't think that's in scope for the Rook Manager module, because it would mean going outside of Kubernetes, and that's a bit out of scope. I don't think it.
Well, the way I interpreted that would be if the Rook deployment is constrained to a label on nodes, like a Rook label, then it would add that label to more nodes. So it basically controls a subset of your Kubernetes cluster that Rook is running on. That was the way I would interpret that command.
The problem is that this is
maybe not
a user-defined label in Kubernetes. So you would kind of have to. Oh, that was a year ago. I don't know if that's still the case.
You'd have to. The permissions would change.
Yeah. Now you have to be intelligent in the way to which label do you use.
Yeah.
And make sure that you add the corresponding label to the Ceph clusters here.
Okay. So that might be something. Yeah, that may or may not make sense. Okay, so for monitors, we can change the number of monitors, but we can't use role placement because of all the labels and host lists and stuff. Managers, we don't let you scale managers in Rook. We don't let you, all the daemon commands won't work. OC device LS would work if you run that discover pod, but just lots of questions there. Okay, so Orch LS and Orch PS, those need to get fixed. That's our low-hanging fruit. Looks like it's just a bug.
Orch apply LGW used to work.
Yes. Yeah. So basically it feels like the priority list should probably be Orch LS and Orch PS, make those work. Then make Orch apply RGW work. So fix that. And then same with FS volume create. And then make the ingress controller work. Oh, that one's going to be complicated. Maybe NFS would come next before that.
Yeah, I would concentrate on the gateways. LGW, MDS.
MDS, yeah.
And
first,
also.
Orch LS and Orch PS, I think those are the first things we got to fix. Yeah. but I mean, we're still sort of kicking the can down the road. It seems like the really big questions are if and how we deal with OSDs with bare metal devices, and or how do we extend the Orchestrator interface so that we can talk about dynamic provisioners and persistent volumes. And if we create an interface to do that, like is there a matching Ceph ADM implementation? Like, do we make a sort of a command that's like create an OSD somewhere using a device that looks like this and make Ceph ADM's implementation like look at its device inventory and try to find something that matches?
Yeah,
Or
that
is it
could be
really just
interesting.
like a totally divergent thing where like there's a set of services that only work with Rook and there's a set of services that only work with, or APIs that only work with FADM?
I think the auto supply still works with Rook, even for PVs. By no means any feature. So, but I think the general approach of using drive groups is independent of if we use PVs and LSO or if we use bare metal. It turns out that we already were able to integrate the existing way of doing bare metal with Rick already with drive groups. So
yeah, that makes sense. Yeah.
I think drive groups are so flexible that we can definitely support a subset of the features of drive groups with PVs.
Yeah.
Maybe we need to add stuff, but I think they're flexible enough.
Yeah. Yeah. Okay. Hey, Jeff, are you paying attention? Are you here? Maybe not. Yeah, I mean, it feels like this like how much effort do we want to invest in making Rook work on bare metal? Question is sort of the big one, but I guess that's a question answer in a different meeting.
I really think, I really have the perception that Rook folks are less interested in bare metal and more interested in persistent volumes.
Yeah. Message I get from product management is a little bit different. But
hello, can you guys hear me?
Yes, now we can hear you. Yeah.
Beautiful. I sorry. I would think yes. In the case of OCP does have some interest in bare metal. So as a result, in those cases, Rook will be required, and I think I think it will be something that will be needed, right? So so yes.
Bare metal via LSO or bare metal via direct VMs and Ceph volume?
I think LSO. If it's OpenShift, then it's going to be LSO, right? Is that right, Jeff?
Directionally, that's where they want to. There's still a lot of lackings there as well, I believe. But yeah, we got that's the direction they would like to head in, and yes. So.
Okay. Well, okay. Yeah. So there's probably a discussion that we need to have with somebody from Rook, probably Besh and Han or Travis, and then somebody on the LSO side, and just understand what the path forward for carving up an NVMe into multiple LVs should be, because that's not something that LSO does today. I understand it.
Yeah. This brings me backstage to a conversation we had a while ago about sort of the solution level discussions. We a lot of times talk about it at component level stuff. We're going to set up meetings, follow on. This would be a nice, type of topic for that, agenda, right? I mean, from the point of view of end-to-end solution, no? I mean, or is it, because it really does cross a lot of boundaries, right?
Yeah. I guess I'm not remembering what discussion that was, but I mean, we just need to get these like 3 groups to talk
Well,
Whether,
I agree. But I
yeah,
mean, overall, we're going to set up a venue. It was in the context of the solution, end-to-end stuff, more or less dashboard related, but it's all encompassing, and we wanted to have discussions occasionally on, the solution level stuff because a lot of times we're stovepiped in the components, remember? And that
yeah,
was,
yeah.
we had the conversation a month ago, or is it even longer? I'm losing track. And,
I can't remember. Yeah,
you had said, yeah, this sounds like a good idea. We should set up a venue to do that, and maybe this is one of those topic areas to throw in that
yep,
bucket, right?
yep. Okay.
Thanks.
Okay. Well, so in the short term, I think we have a whole bunch of questions to answer on OSDs on both fronts, bare metal and not bare metal. But in the meantime, Joseph, maybe the next steps are to look at OrchLS and OrchPS and just figure out why the timestamps are screwed up. It's probably whatever the datetime conversion is that's happening in the manager work module isn't agreeing with whatever's being done in the orchestrator or something. I'm not sure exactly, but hopefully that one isn't too hard to track down. Just starting with their Minikube environment and going into the sandbox and making sure those commands work, or if they don't work, tracking down with looking at the traceback, hopefully it will be enough. And then we can move on to RGW from there. And the Rook huddle is not quite done yet. Maybe I just jump over there really quick and just see if they know. Do we know who the right person to talk to on the LSO side is? Sebastian Han gave me a couple names.
Sahina or Rohan Joseph, I believe, would be the ones.
Rohan Joseph, or yeah. Okay. Okay. Sound good?
Okay.
All right.
We're done?
Yeah.
Perfect. Then, yeah, and talk to you next week.
Bye.
Bye.